So everybody got that pseudo homework I passed around? Send it to your email.
Not for the 570 class.
We did kill.
Well, that's why I'm not close. Okay, so the function is of 5 variables, A through E, and it's given to you in expanded sum of product form. Now I went ahead and reduce it down to the minimum sum of products. Again, it may not be a unique solution. And then to implement it with standard gates. All right, so what we have is A, B, let's see how many terms we've got. 12 terms. Yeah, that's right. We'll just go ahead and directly put them onto the map. Okay, we'll let the top one correspond to our variable E equals 0 and our bottom set of 16 to E is equal to 1. Okay, so we got to put our possible combinations of inputs into a gray code. So let's take a look at the first term. It's A, B bar, C, D, E. So the only one that's negated is B. So we're down here someplace to put a 1. Okay. So it's A is going to be a 1, B is going to be a 0, and then C and D are 1. Everybody okay? For that first term, we're going to put a 1 there. Okay, we got 11 more of these guys to do. So the next one is A, B, C bar, D, and E. So the C is, so we're still down here, right, because E's a 1. So it's A, B, we're along here someplace. C bar and D's a 1. Everybody okay that we're going to put a 1 at that spot? Then we've got A, B, C, D, E, so everybody's a 1, so that's going to correspond putting a 1 there. Next one, A bar, and everybody else is a 1, so again we're down here. A's a 0, but everybody else is a 1, so that should put us a 1 there. Has everybody got? Well, I'm assuming you'll have access to this thing here, so I'm not going to go ahead and put those on the board explicitly. The next one, everybody's a 1 but D. So again, we're down here. So 1, 1. D is, we're there. Yep. Next one, C and D are knots, and E's a 1. So we've got C, D, so A and B are 1, C, D's a 0. We're going to put a 1 there. Next one we've got, everybody's a 1, but E's a 0. So we're up on the top group of 16, and that'll be a 1 in that particular slide. Next one, we've got E bar, so we're up here, and we've got A, B bar, C bar, D. A, B bar, C bar, D. Did I do that one correct? Yes, okay. Next one, E's a 1, so we're down on the bottom group of 16. We got only D is a 0. So we're at 1, 1, D's a 0 here. Did I put that one down twice?
Yeah, that one's already a term.
Doesn't matter, that, I mean, that could happen, right? But you can collapse that down into one group. Okay, so we're gonna end up with one less 1 in our group here. Next one is A bar, see, E is a 1, so it's A bar, B, C, D bar. So we're down here, A's a 0, but everybody else is a 1. And I must put that one down twice too, right? A bar, B, C, D. Yeah, so I already covered that someplace before. So random knotting these things was can provide unique variables here. Where are we at? Now we're at A bar.
E bar, wouldn't that be the top? It'd be at the top and on
Yeah, but I was doing the one above that. And now we're doing A bar and E bar.
Okay.
Okay, so now we're doing this guy up here. So it's A bar and everybody else is a 1. So we'll put a 1 there. And our last one is E's the 1, and it's A, B, C bar, D, E bar, D. And looks like I had included that one in there before. Everybody all right with this? Am I done? What do I need to do? No, not yet. I gotta put zeros in there. Okay, you will get dinged if you don't include the zeros. Why? Because it's possible that there are don't care states that may be given to you, and those would be put in as a yes. Okay, any group of 32 ones? No. 16 ones? No. 8 ones?
If you
8 ones?
if you stack them on top, you can make 8.
No, I don't think you got enough stacks here.
With the can they not combine long ways when they're stacked with the
Well,
groups?
if they're stacked, if you got a long, if you're talking about, if you had all of these ones, all of those ones, now you stack them up, now you got a group of 8.
Okay, so you can't take, like if you had 4 on the bottom and 4 on the top, but they were just off by like one row, they don't.
Can't do it.
Okay.
Can't do it. Groups of 4, okay? So we've got to go for the low-hanging fruit first. We got a group of 4 there. So my function will be what? How many variables am I going to need? No. 3. How many are not, how many are changing? 2. And so we don't include those. So this is going to be A, B, C and D is changing, we don't include it. We don't care what the C and the D are. They can be zeros and ones, does not matter. And then E. Is that all right? Any other groups? I mean, we still got 1, 2, 3. We got 4, 5, 5 more ones to cover, but can we put them into a larger group? Okay, any more groups of 4? Okay. Do you see that these guys and these guys are stacked on top of one another? Okay. Okay. So that is going to be what? Okay, are we going to include the A variable? No, because it's changing. Are we going to have the B variable? Yes. So this is going to be B, all right? What is the E changing?
Yes.
So we're not going to include it, correct? So it's going to be CD, like so. All right, we still have some lonely ones that have to be covered. But can I put them into a larger group, or do I have to cover them singly? Okay, what about this guy down here? And put it into a group of 2 like that, and that's going to require then how many variables?
4.
4 of them. There's only one variable that is changing, and that happens to be B. So we will not include B. So we're going to have A, and we will have C, D, E. Fortunately, we're not ending up with any negative terms. Maybe we will, or not terms. I've got one more 1 to include. That's this guy. Can I stick him into a larger group?
No.
Answer is no. Okay, I can't get to this guy through a path where only one variable is changing. Can't get to that guy. We're going to have to cover this guy all by his lonesome, and that's going to be A, B bar. Now what?
C bar.
C bar,
D.
D,
And E bar.
and E bar. Doing okay? So to implement this thing, I'm going to have my variables A, B, C, D, and E. Those are going to be the input variables. How many not variables do I have to generate inside the box? 3. I've got to generate a B bar, C bar, and a D. And then we said C bar and E bar. Okay, again, input to your system are only A, B, C, D, and E. You don't have the knots. If you need them, you have to generate them with the gate. So we need a 3-input AND gate, and we're going to include A, B, and C. Okay, so this term here is A, B, and C. Then we need B, C, and D. So B, C, and D. So that line there is going to be B, C, D. Then we need A, C, D, and E. A, C, D, and E.
Why do we need A, B, and C?
For which one?
The first one.
Oh, I'm sorry, because I thought that was it. We don't. We'll fix that. We need A, B, and E.
the.
Did I erase the wrong thing?
You erased the not the. You erased the
You
line
erased
from
under
the C to the not.
instead of the A.
Ah. I don't, yeah, sorry about that. And then this one is. We need E, right? Look better?
Yep.
Still confusing, but better. We got one more term to generate, and has to have all 5 variables in it. So let me just put them here. This is going to be A, B bar, C, D, and E. E bar. Kind of running out of room. Got all those 4 terms now. What do I have to do with them? Put them into an OR gate. And this will be my function F here. So in terms of the number of gates, needed 1, 2, 3, 4, 5, 6, 7, 8 gates. Number of inputs would be what? Let's see. 1, 2, 3, 4, 5, 6, 7. I think I counted 22 inputs there. Going back to the original expanded sum of products, though, I would need what? Still need my 3 inverters, but then I would have to have, let's see, we ended up with 12 ones, right? I had some duplicates in there. So we'd have to have 10 5-input AND gates, 1 10-input OR gate. You see, you don't want to implement expand a sum of products. Questions on that?
Like if we run out of space on the test, we're about to use that shortcut you did for A, B naught, C.
You won't run out of space.
Okay.
If it's pretty clear, I'll have to hammer you too hard.
Is the purpose of these lines just supposed to help us visualize? Or?
Yes.
Okay.
Well, when you are implementing gates, okay, hardly anybody implements a big old hairy logic function with discrete gates. Okay, they will do it with things called FPGAs, field programmable gate arrays. But back in the day when everybody was doing discrete gates, it's 50 years ago now, you had to have a wiring diagram. So you had to know that this guy went to this guy here. Okay? And so in order to, especially when you were doing a technique called wire wrapping, so you have a square pin here like this, and this guy would go to something, an input or an output. You'd have another square pin over here. Then you take a piece of wire, like so, that is insulated here, and this guy, about 1 inch of uninsulated wire, put that into a tool, and it wraps the exposed wire around those guys. So when you were doing this, you would do a continuity check. So you would have every possible input output on a gate, and then you would say this guy goes to this guy. And then after you did the wiring, you could take a continuity meter, DMM, check and see if there was actually continuity there. So it helped for visualization for the most part. And you can see it can get out of hand